Hey everyone, Mr. Smith here. We've already gone over 2 fraction videos. We've done fractions in general and how to represent fractions. Well, now we're going to go into a different realm of fractions. I was asked this question by one of my students. Sir, we know that a fraction is when the numerator is smaller than the denominator. But is there ever a time when the numerator is greater than the denominator? And that is where we are now. We are going to be talking about those type of fractions. Welcome to the realm of improper fractions and mixed numbers. Now, when we work with fractions, we would like for them to be what we call proper. When a fraction is proper, the numerator is less than the denominator, as you see right here. But as I say here, this is not always the situation. In some cases, we're going to have to work with what are called improper fractions. So an improper fraction, ladies and gentlemen, is a fraction in which the numerator is greater than the denominator. A couple of examples here for you are like 3/2, 5/4, and 15/8. So, these are improper. Even just saying them sounds kind of weird. 3/2. I don't like that. 5/4. 15/8. Can we correct these? We can. We can correct these improper fractions by rewriting them as mixed numbers. A mixed number is a number whose value is represented by a whole number and a fraction. A couple of examples are like 2.5, 1 3/4, and 4 3/10. In order to convert an improper fraction to a mixed number, we use a strategy called Tebow. This uses division. So, like I told the kids earlier in the year, division is going to come back one way or another. Now, Tebow is basically an acronym that stands for top in, bottom out. I'm going to use a little bit of an algebraic example here. Let's say we have a numerator which we'll call n and a denominator which we call d. Basically, Tebow tells us if we use long division, the numerator goes inside the box, top in, the top number goes inside the division box, bottom out. The bottom number of the fraction goes outside. To make this easy for you, it's like taking the fraction 3/2. If I draw a division box, the 3 would go on the inside and the 2 would go on the outside. And that's how you would set up the Tebow strategy. Now, to obtain the mixed number, the following parts represent the parts of the mixed number. The quotient after we divide is our whole number. What's left over, and these will have leftovers, the remainder is our numerator, the divisor is the denominator. I do want to scratch that. The remainder may sometimes be 0, and if that's the case, it's a perfect whole. But in this case, all the examples I'm going to show do have a remainder. So, we'll convert these examples of improper fractions. Now, I'm going to switch between long and box division just to have all the kids, because some kids are comfortable with long division, some are more comfortable with the box division. So 3/2. Using Tebow, long division style, and box division style. Don't forget your multiplication symbols in the corner. Top in, bottom out. The top number is 3, so it goes inside the division box and the box division box. Bottom out. The 2 goes on the outside. And now we have our division problem set up. This is a basic one-step division problem. I will admit, sometimes you are going to have double-digit inside numbers, and that's okay. We just follow the rules like we normally do. So now, we just do our long division and our box division. How many groups of 2 can we get from 3? If you say 1, you are correct. That was dad divide. Remember our division family. Dad divide, mom multiply, sister subtract, brother, depending on the strategy you use. If it's long division, it's brother bring down. If it's box division, it's brother bring over. Then we go to rover, which is repeat or remainder. And then we have cat, which is to check work. So mom multiply 1 times 2. 2. So we subtract. And I have a remainder of 1. And the same thing works here. Subtract 2, 1, remainder 1. Now, look at what it says here. Quotient. My quotient is 1. So therefore, my whole number is 1. And I make a fraction bar. My remainder. So I'm going to put a W for whole number. My remainder is my numerator. That goes 1. The divisor, which is the outside number, is my denominator. Sorry. That is 2. And that's my mixed number. 1 and 1/2. Let's go ahead and look at another one. We're going to use the examples from the improper fractions. Here's the next page. Five fourths. 5/4. If you want to go ahead and pause the video real quick, I'll stop for like 3 seconds so that we can pause it and try it yourself. Welcome back. Let's go ahead and try this out. Top in, bottom out. 5 is my top number. It goes inside the boxes. 4 is my outer. We also have, how many groups of 4 can we get from 5? 1 group. So we follow. Oh, another remainder of 1. I do want to stress this is not always going to be the case, and you're going to see that. Your whole number is not always going to be 1, and your quotient is not always going to be 1. So we have a remainder of 1. My whole number, and I'll use this for an example. Oh, I'm so sorry. I don't know why I'm so tired. My whole number is 1. I put my fraction bar. My numerator, which is from the remainder, is also 1. And my denominator is 4. So again, 1 and 1/4. I do want to stress, these guys are equivalent to each other. They have the exact same value. So take a look. I'm going to show you through a picture over here on the side as proof. I'm going to draw 2 circles. Now, according to this, it's 5/4. So 1, 2, 3, 4, 5/4. There's 5/4 there, but wait a second. If I recall, 4/4 make a whole. And this one has 1 out of 4. So together, 1 and 1/4. Now let's go to the next one. 15/8. 15/8. I'll give you 3 seconds to pause the video and try it yourself, and let's see how you do. Alright, welcome back. Let's go ahead and get to this. By this point, everyone should become very proficient with their division skills, particularly when dealing with their times tables. How many groups of 8 can I get from 1? None. So, go through the entire division family step. 1 with the remainder 7. Same thing over here. How many groups of 8 can I get from 1? 0. Same thing. Once again, whole number, 1. Numerator, 7. Denominator, 8. 1 and 7/8. Again, if you noticed, our whole number was once again 1, but I cannot stress it enough, that will not always be the case. And in this case, our numerator was actually 7, so it was a different number. Do not think that it's always going to be a 1 whole number or a 1 numerator. You just have to do the division to get that part checked out for you. So now to help us out a little bit, here's what I'm going to do. I'm going to write our fractions that we got. 1 1/2, 1 1/4, and 1 7/8. The reason why we're going to do this is because we're going to revert them back to their improper fraction form. Why is that, you say? Well, we got to check our work. To check our work, we reverse the Tebow strategy by using what's called the oval. You're going to see why it's called the oval in a little bit visually. Just like how multiplication are opposites of each other, for my strategies, Tebow and oval are opposites of each other. And you're going to see why. To do the oval method is very simple. Starting from the denominator, you keep the same denominator. Starting from here, you draw a clockwise curving arrow. You write multiplication on the bottom. You draw another one, and you write addition on the top. What is 2 times 1? Based on our times tables, we know that 2 times 1 is 2. And then 2 plus 1. And we got our improper fraction back. 3/2. So go ahead and take a few seconds. Try the next one on your own. All right, let's try it. Again, keep the same denominator. Multiplication on the bottom, addition on top. 4 times 1, 4 plus 1, 5. And we got the improper fraction, 5/4, back again. Hello, 5/4. Now, the last one. Go ahead and try that one on your own. I'll give you a few seconds. Welcome back. Let's try this one. Again, your curves and your addition, or your multiplication and addition, keep your same denominator. 8 times 1, 8. 8 plus 7, 15/8. Welcome back, 15/8. And that's how we convert improper fractions to mixed numbers and how we reverse the process. If you have any questions, please contact me on Class Dojo or contact me at the school. Thank you. Enjoy the rest of your evening or afternoon. The next video will be up shortly.